Kim, are you allowed or not?
Okay. Let us talk about concentration of solutions. So when you see that word concentration, you should know that it designates the amount of solute dissolved in a certain, like you need to know the amount or find the amount of solvent. Now, there was a question on your last test. I'm trying to remember exactly what it said, but basically it asked you about a solution, and it asked you to discuss all terms. And some of you, in fact, I don't know if there's anyone in the room that didn't lose at least a point on that. When you talk about solutions and you're asked to explain one, you should be talking about these words. A solution has a solute, it has a solvent, it's called solvation. There's dissociation of ions, there are cations and anions present in the solution, because I ask you to talk about a salt, a soluble salt. So think about that the next time, like what kind of a solution are you being asked about, and what are all the proper terms that apply? Because that's a pretty easy thing to discuss, you just have to be sure you include all the parts. So I can say that the greater the amount of solute, the higher the concentration. If I have two beakers and they both have 100 milliliters of solvent, and in one beaker I put 0.5 moles of a substance, and in the other I put 1.5 moles of the substance, the one with the 1.5 moles is of greater concentration than the one with 0.5 moles because they're in the same amount of solvent. Whenever I want to express concentration, we use the term molarity. You've heard it a lot, but we haven't, we've barely touched on it. The symbol for molarity is a capital M. And it has to be calculated in a very specific way. What is this? I don't know what this stuff is. I can say that molarity oh wow, I really need to move this. It's not giving me full screen for some reason. Okay, anyhow, I can say that molarity is equal to moles solute per liter of solution. So it looks like this. Capital M equals moles per liter. So if I have something like, let's say I have a 5 molar solution. That means I have 5 moles of solute per 1 liter of solution. Notice I didn't say 1 liter of solvent. I said 1 liter of solution. From now on, when you see this word solution, because you'll start seeing it a lot more, a lot of times it'll be SOL or SOLN for solution. So we can work some really easy problems with this stuff, and then they become more and more difficult as we go. So let's get an example of a simple one in your notes. Let's say calculate the molarity of a solution made by dissolving 23.4 grams of, what shall we use, sodium sulfate and enough water to form 125 milliliters of solution. I'll let you write that. Then there's one thing I want to point out. So first of all, notice you're given a mass here. What do we need to do with that, Carter? Yep, so when you're given a mass, you know in there you've got to get that to mole. And then also, notice how it says, it doesn't say it's dissolved in 125 milliliters of water. It says it's dissolved in enough water to make 125 milliliters of solution. So that's a different kind of wording. That's telling you, this solution is telling you this is the combination H2O and sodium, what do I have here, sulfate, and your Na2SO4. So you have to look for that. If it said 125 milliliters of water, when you dissolve that sodium sulfate, you're going to have more than 125 milliliters of solution. Your volume will increase when something dissolves. So normally they're worded like that. So let's work through this problem. We're going to do exactly what Carter said. The first thing we're going to do, bless you, is we're going to convert grams to moles of the Na2SO4. So do that. I've got 23.4 grams Na2SO4. I want to know how many moles that is. So find your molar mass of sodium sulfate. Is that what you got, Annika? Is that what you got, Carter? Yeah, okay. All right, so let's do that. 142.1 grams. Plug that into your calculator. Tell me how many moles that is. Well, it's going to be point something. Oh, that's not right. Lauren, what'd you get? 1.6 what? All right, so we'll make it 165 mole. All right. So we've completed the first part of what we need to do. We know how many moles we have. And then we want to know, I think I said calculate the molarity. What's the molarity? It is the moles divided by the liters. So I now have the moles. I have 0.165 mole Na2SO4. How many liters of solution do I have? 0.125. So what does that work out to be? What'd you get, Rachel? 1.32, and this is the way I would write this. 1.32 molar solution Na2SO4. And that I would have to write that whole thing to be 100% correct. Hey, welcome.
Hey, here you go.
Oh. All right, simple enough. If you're given grams, you've got to get to moles. If you're given something other than liters, you have to get to liters. So I can use it to express the concentration of a solution in terms of molarity, but I can also express concentration in another way. And it's called in the form of electrolytes, and we'll talk about it a little bit. So let's say I want to express the concentration of an electrolyte. And this is more just so you have like a little taste of it. It's something that's used a lot more in bio or biochem. If you take upper level anatomy and you get into the cellular processes and like the things that go on in terms of muscle contractions and all of those kind of things, you'll talk about the concentration of electrolytes because they're super important. I'm going to say in cellular and metabolic processes. If your electrolytes are out of balance, your entire body is out of balance. If you have a person that lots of people when they get older develop a condition called congestive heart failure. One of the things they do if somebody is having congestive heart failure, that's where like water builds up around your heart and their legs will swell and their hands will swell. All of those things start happening, so then they give them a drug called Lasix. Lasix is a diuretic. You know what a diuretic is? It flushes the water out of your system. When it flushes the water out of your system, it also flushes the potassium out of your system. So potassium is an electrolyte that's in your body all the time. If you don't have enough potassium, your brain doesn't work right and your muscles don't work right. So when we prescribe Lasix, we also prescribe actual potassium tablets. If you have an individual who is paranoid schizophrenic or bipolar, they have a chemical imbalance of the electrolyte lithium in their brain. So when we medicate them, we also prescribe lithium, because then it takes care of that part of the brain that's not quite firing right and helps keep things in balance. When people who are bipolar or paranoid schizophrenic, when their lithium is not right, that's when they start hearing like they think the Russians are in their car trying to get them, or living in their ceiling trying to get them, all those kind of things. So I could go through a million different things like that, where if your electrolytes aren't right, you're not right. But anyhow, so we use it a lot more when we're talking about biochem, which is extremely fascinating stuff, or when we're talking about just more advanced anatomy. But anyhow, you have to know how to express the concentration of electrolytes to know how to prescribe things and to know how it all works. And it's really pretty easy. You want to think, you'll just be given at this point some kind of an ionic substance or an ionic compound. Because most of the time, those electrolytes in our body start out in the form of some type of ionic compound. We know if I have an ionic compound, I get ions when it dissolves. We know that. And the concentration depends on the chemical formula, the way we express it. So if I said that I have a 3.0 molar, I'll just stick with the NaCl, solution of sodium chloride. If I'm asked to express the electrolyte concentration, it's pretty easy because it's a 1-to-1 ratio. I would say I have 3 molar sodium ions and 3 molar Cl minus ions. So I just apply that molarity to the ion. But I have to pay attention to how many of them there are. I'll show you that in a second. Let's say I have a compound like, 3 molar, we'll use that sodium sulfate from before, Na2SO4. And I put it into solution and it dissociates and I get my sodium cations and my sulfate anions. I have to actually apply this 3 molar, think of it as a multiplier of the number of ions. So it's kind of like a coefficient out in front of a math problem. So then I would go and I would say, actually, how many sodium do I have in that formula? 2, right? So I would have to go 3 times 2. I actually have then 6 molar sodium ion concentration because I had 2 of them, so I took my 3.0 molar times the 2 to get my 6. And then when I look at my sulfate, I look at the whole thing as a unit because when it dissociates, it's going to stay together with its charge. I only really have 1 sulfate in that particular compound that's going to dissociate. So I would say I have 3 molar electrolyte concentration of the sulfate ion. That's how I would talk about that. Does that make sense? Okay. Gonna have to get more paper. Okay, see if you can do this one. What's the molar concentration of each ion present in a 0.025 molar aqueous solution of calcium nitrate? All right, you figure it out. Okay, let's talk about it. What is, Max, what's the chemical formula for calcium nitrate?
CA parentheses NO3 parentheses.
Okay. All right. So when I break it apart, I have Ca2 plus and I have NO3 minus, correct? Everybody agree with that? All right. When I look at this formula and I ask you to express ion concentration, Maddie, what would you tell me about calcium? What did you have as its concentration? Yep. 0.025 molar. And Josh, what did you have for nitrate?
0.05 moles.
Ooh, I didn't leave enough. Yes. So that's pretty easy stuff. Questions? Bless you, Avery. All right, so now let's talk about converting, doing some conversions.